Today we are going to solve LeetCode 283 and it is called Move Zeros. It's an easy problem. Okay. Given an array called nums, write a function to move all zeros to the end of it while maintaining the relative order of non-zero elements. Okay. So here's an example and we have two zeros here. So we will have two zeros at the end and we have 1, 3 and 12 in that order. So we have this as a result. And there's some note here. You must do this in place without making a copy of the array. And you must minimize the total number of operations. So okay, this is this part actually makes this problem a little bit harder, but it's still easy. So what can we do? Let's see. Let's take this example and work on it, right? So okay, let's say we start from this index and we are just going to do some things with these indices. And let's keep a variable. Let's call this next available. Okay, and this thing basically will keep next available position for the current non-zero element. Okay, so we are just going to keep track of positions that are available, like 0, because otherwise this would not be available, for the first non-negative integer, non-zero integer that we will see. So we start from this position. Let's keep that thing. Let's call that next available, as we said, and this becomes 0 at first. And our I is 0, and apparently it is 0. We do nothing. So we move I. And we see a non-zero element and we put it to the next available position, which is right here. And if this next available position is different than I, we make this position 0 because this becomes available. And then we move I again. We see another 0, so we move again. And we see a non-zero element. So what we do is, by the way, we updated this to 1 because the next available position was 1. We take this element and put it into the next available position of the array, right? And then we make this position 0 because next available position and I are not the same. And we move I again and we see another, by the way, we updated this again, I'm sorry. And we see another non-zero element, so we make this reside right here. Then we make this 0 as well and we finish. So at the end, as you can see, we have the result itself. So why this works is because we start from left hand side and we always update next available position. So for each non-zero element we make just one operation. We take it and we put it inside the next available position. So what if we started from like 0 and our array is already handled like this. So we start from this position and our next available is 0. So we put it inside itself. And we do not make it 0 because I and next available was the same. So we move I and we see that this is the next available now because we update this as well. So we see that it is a non-zero element, so we put it into the next available position, which is itself. And we do not make it 0 because the I and next available are the same. So we update this to 2 and we move on with I. You get the idea, so it will not change anything in this array because this is a valid array as they want, coding. So let's call this variable nxt as in next, and let's iterate through our array. So what we are going to do is, whenever we see something that is not equal to 0, we are just going to take it and put it into an nxt position because that is the next available position, right? And if our I is not equal to nxt, then we are just going to make nums I is 0 because otherwise we would take this and put it inside and we would make it 0 and that would mean that would be meaningless. So what we're going to do next is just update this position, and I think we are done. Let's run this code. And this works apparently, so submit it. So apparently this works. It's faster than 91% of the codes. And we use no extra space other than this variable. So thank you for watching.